2.1 average and instantaneous rate of change. So let's do a little refresher here. Rate of change is another way of saying slope. We can say slope is the change in y over the change in x. Looking at a graph, we often refer to it as rise over run. And then if you recall the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. Average rate of change on an interval a to b is represented by the following function, f of b minus f of a over b minus a. Average change from a function says find the average rate of change of f of x equal to natural log of 3x over the interval 1, 4. Well, this is the same as doing f of 4 minus f of 1 over 4 minus 1. So this is the natural log of 12 minus the natural log of 3 over 4 minus 1. If you recall from your properties of natural log, that if we do natural log of b minus natural log of a, that's the same as saying natural log of b divided by a. So technically this is the natural log of 4 over 3. And it is okay to leave your answer in this term. If you want to simplify to decimal, you can. Just make sure you're using 3 decimal places. But I would try to avoid that and just leave it in terms of natural log. Okay. The reason for that is on the AP exam, you do not need to simplify numeric answers. So numeric answers don't need to be simplified. Okay. Because what they're checking for is your calculus skills. They are not checking for your algebra skills. Okay. Now let's say average rate of change from a table. So it says find the average rate of change over the interval of 2 to 30. So that's the same as saying f of 30 minus f of 2 over 30 minus 2. F of 30 is 7 minus f of 2, which is negative 2 over 28. So this gives us 9 over 28. And again, even leaving it like this would be okay. Only if you're not 100% sure. Like let's say you forget minus a negative is a positive and you don't want to end up putting, let's say, 5 over 28. If you leave it like this, it would still be correct. Okay, average rate of change. So when you think average rate of change, I want you to think slope of the secant line. Okay. The following quotients express the average rate of change of a function over an interval. So you could see it as f of a plus h minus f of a over a plus h minus a, or f of x minus f of a over x minus a. This is the slope of the secant line. Okay, so remember the slope of a secant line, we need 2 points to estimate the slope. So let's say we had our function here. Okay, this is our function f of x, and we are trying to approximate the slope using these 2 points. Okay, this is the secant line. We would say at these 2 points, this is a f of a and a plus h, f of a plus h. Okay. Same with the other one, but instead of saying a and f of a and a plus h and f of h, it's a and f of a and x to f of x. So you could say that this is also x and this is also f of x. Okay. I want you to keep in mind that h is the horizontal distance between the two endpoints. So for example, this would be h, the distance between the two. So this is the horizontal distance between two endpoints. Okay. Instantaneous rate of change is the slope of the tangent line. I want you to think of instantaneous rate of change as the limit as h approaches 0 of average rate of change. It says the following limits express the instantaneous rate of change of the function x equals a. So we have the limit as h approaches 0 of f of a plus h minus f of a over h, and the limit as x approaches a of f of x minus f of a, x minus a. So you'll notice again, these are similar here. The only difference, that instantaneous rate of change is looking at the limit as h approaches 0. Okay. The reason for this is when we are trying to find instantaneous rate of change, or the slope of the tangent line, we're only looking at one point that passes through that function. And we're trying to see that as x gets closer to a, the secant line begins to resemble a tangent line. Okay, and we'll see that here. So again, let me write this as the slope of the tangent line. Again, if you were to look at this graphically, we would have our function, and then we would have a and a plus h. Okay, the distance between the two being h. And then here we would have f of a and f of a plus h. Okay, so those 2 points that we know are from the secant line. Okay, and what we're trying to do is we're trying to estimate that secant line to start to resemble a tangent line, because the tangent line is eventually only going to go through one point. Okay, so we're estimating the slope at a single point, x equals a. Also, nope, I already mentioned that. Okay, good. And also you could see this right here, this could be x. Okay, and it would still be f of a plus h, or f of x. Okay, in this example, it says find the instantaneous rate of change of f of x is equal to x minus x squared at x equals -1. Okay, so first we're going to use the first definition, limit as h approaches 0. Okay, so first I'm going to find f of a plus h. So f of a plus h is going to be equal to the same as saying that a is equal to x. So a is equal to -1. So this is the same as saying f of -1 plus h. And we're just going to plug in -1 plus h anywhere we see an x. So this is going to be -1 plus h minus -1 plus h squared. Okay, simplifying this, I have -1 plus h minus, foiling this out, I would get 1 minus, let's see, 2h plus h squared. So this is -1 plus h minus 1 plus 2h minus h squared. Okay, which is -h squared plus 3h minus 2. Okay. Then I'm going to find f of a, or in other words, f of -1, which would be -1 minus -1 squared. This is negative 1 minus 1, which is negative 2. Right, negative 1 minus, that becomes positive, yep, negative 2. Okay, and then now I'm subtracting both of these. So this is negative h squared plus 3h minus 2 minus a negative 2, which means this is negative h squared plus 3h. Okay, and then remember the whole thing was divided by h, so I know I can cancel out an h from each of these, and I am left with negative h plus 3. I know h is going to approach 0, so when h approaches 0, I'm left with 0 plus 3, which is 3. Okay. Now one wants me to do the same thing, but using the other version of this. So we have f of x minus f of a. So f of x would be x minus x squared minus f of a. We already know that f of a is the same as saying f of negative 1, and f of negative 1 is negative 2, so minus negative 2. And this is all over x minus a, so minus negative 1. So we have x minus x squared plus 2 over x plus 1. Okay, I could rewrite this with my x squared first. So I have negative x squared plus x plus 2 over x plus 1. Take out a negative, and I am left with x squared minus x minus 2 over x plus 1. Factoring this, I have x minus 2, x plus 1 over x plus 1. The x plus 1s are going to cancel. So I have the limit as x approaches negative 1 of negative 1 times x minus 2, which is equal to negative 1 times negative 1 minus 2, which is negative 1 times negative 3, which is positive 3. So notice how I got the same answer for both, which makes sense because these are both just definitions of instantaneous rate of change. Okay, this next part here says to identify the function we're working with, then identify the x value for instantaneous rate of change, or in other words, the slope of the tangent line at a point. Okay, so what we're trying to see is what function this resembles. Well, notice how both of them are limits, right? Which means they're either going to represent one of these two definitions of instantaneous rate of change. Well, since this one has an h in it, I know that this is going to resemble the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so knowing that, I can first see what this original function was supposed to be. Well, since I have this portion here of 4 plus h, I can say, well, 4 plus h could be where they plugged in a plus h, which means a is equal to 4. So if this is where they plugged it in, that means technically this is just x, which means our function is going to be 5 natural log of 2 over x. And then we found our a value, so this is the same as saying a, our instantaneous rate as x equals 4. Okay. Versus this one looks more like the limit as x approaches a of f of x minus f of a over x minus a. Okay, so looking at this, I know what f of x is because it's that very first one right here. So f of x is sine x. And then I know what a is because it's whatever x is approaching. So a is pi halves, which means the instantaneous rate at x equals pi halves. Okay. So that is the notes for 2.1.